All right, so 8-2, what quadrant's that? Let's put our phones away. 1, right? First quadrant. 8 to the right and 2 up. Okay? So if I have my little XY axis, I'm just going to draw it bigger. This would be the 8, this would be the 2, right? You draw your picture. Here's our point up here. Okay, you draw a line back to the origin and a line straight down to the x-axis to get your right angle. Theta is always back here by the origin. Okay, so how do I find the hypotenuse? Pythagorean, right? Okay, so 8 squared plus 2 squared. You could use C, or yesterday they were telling you to use R. Okay, but again, it's just the same as Pythagorean as last week. Okay, so it's 64 plus 4, right? So it's 68. So what's R? Square root of 68, right? Remember, it's the square root of that. Now, can I simplify that? Does 4 go in there? I think it does, doesn't it?
Yeah.
4 times 17?
Yeah.
All right, so what can I pull out front? 2, right? So this is equal to 2 times the square root of 17. Now, here's what I do. These 3 numbers are even, right? So I'm going to reduce it, because I know I'm going to have to reduce the fractions. So I'm just going to divide each one by 2. Okay? So, you know, just the new numbers would be 4, 1, and the square root of 17. Because when I end up reducing my fractions for sine through cotangent, those 6 fractions, you know, I have to put it in the simplest form anyway, right? I'm going to have to reduce it. So I usually try to reduce beforehand. Okay, and again, remember, theta's back here in the corner. All right, so for sine, it's opposite 1 over hypotenuse, the square root of 17. Which means I have to rationalize it. So it's the square root of 17 over 17. What's the reciprocal of sine? One of you in here know. You can tell me. Cosecant, thank you. So just split that. So square root of 17 over 1, which is the square root of 17. Cosine of theta would be adjacent 4 over hypotenuse, the square root of 17. And when I rationalize, it's going to be 4 times the square root of 17 over 17. Because you're going to do what we did up above, right? This is called secant, so the square root of 17 over 4. And then tangent would be opposite 1 over adjacent 4. Okay. You would have had 2 over 8, right? You would have had to reduce it to 1/4 anyway. So I just did it beforehand. That's why I did that. Okay, and cotangent would be 4 over 1, which is just 4. Okay, so once you get your picture, it's just like last week for your SOHCAHTOA. All right? They called it, you know, Y over R for sine. They we said x over r for cosine yesterday, but it's still adjacent over hypotenuse for cosine. All right? So it's just a little bit different labeling, but it's still what we did last week, SOHCAHTOA. Okay? So, number 2 is sine is 7 times the square root of 58 over 58. The cosecant would be the square root of 58 over 7. The cosine is 3 times the square root of 58 over 58. Secant is the square root of 58 over 3. Tangent is 7 over 3. Cotangent is 3 over 7. For number 4, hypotenuse is the square root of 34, so sine is 5 times the square root of 34 over 34. Cosecant is the square root of 34 over 5. Cosine is negative 3 times the square root of 34 over 34. Secant is negative the square root of 34 over 3. Tangent is negative 5/3. Cotangent is negative 3/5. Number 6, our hypotenuse is the square root of 13. Sine is negative 3 times the square root of 13 over 13. Cosecant is negative the square root of 13 over 3. Cosine is negative 2 times the square root of 13 over 13. Secant is negative the square root of 13 over 2. Tangent is 3/2. Cotangent is 2/3. Since they're both negative, it becomes positive for those. And for number 8, the sine of theta was 1, the cosecant was 1, cosine of theta was 0, secant is undefined, tangent of theta is undefined, cotangent of theta was 0. The number 8. Okay. That was a quadrantal, right? Let's go over that real quick again. Okay. So the point was 0, 2. So if I put that on my xy axis, all right, remember this is x, and this is y. We all know that, right? All right, my x value is 0, but I don't go anywhere. My y value is 2, so I go up here. Okay? I can't draw a triangle because it's laying on the y-axis. Okay? So you know what your x is. You know what your y is. R is always the distance from the origin to the point. And it's always positive. So R is 2. Okay? And then you got to find your 6 trig ratios, right? So yesterday we said that we think about the alphabet. Which one goes over R, right? What comes first, cosine or sine in the alphabet? Cosine. What comes first in the alphabet, X or Y? X, all right? So since sine came second between cosine and sine, so remember, the sine is the Y over R. Because sine comes after cosine in the alphabet, Y comes after X in the alphabet. That's how I remember which one's which. I know it's over R. I know R is the hypotenuse. Okay, so my Y value is 2, and my R value is 2, so that answer is 1. Okay, and then again, I know the cosecant is the reciprocal, which would be R over Y, which is still 2 over 2. Okay, the cosine, it comes before sine, so X comes before Y. So this is X over R. My X value is 0, my R value is 2, so 0 divided by 2 is 0. For the secant, it's R over X, which makes it 2 over 0, which is undefined, right? You can't divide by 0. So I can't really draw a picture for those. Those are where the quadrantals. This degree measure would be a 90 when you're up there. We talked about that yesterday, right, Nathan?
Mm-hmm.
Right? Remember, this was 90 or pi over 2. Over here was 180 or pi. Down here was 270 or 3 pi over 2. These are things you should know. This is 0, 360, or 2 pi. Okay, sometimes they're going to give you problems in radian form. Okay, so you need to learn them. All right, so this one we're doing is basically we're doing sine, cosine, and tangent of 90 degrees is what we're doing here. Okay, so tangent is y over x. All right, so the y is 2, x is 0, so that's undefined. And for cotangent, I should have put theta, right? That's x over y, which is 0 over 2, which would be 0. So that's how you do something like that. I wanted to go over that again. Some of you may have forgot. All right, it says for the next group, 10 through 20, it says evaluate the trig function of the quadrantal angle or state that the function is undefined. Okay, so we're at 270. Okay, so we're down here. That's 270. All right, so my x value is 0 and my y value can be whatever I want. You can pick any number down here. So, Matt, pick me a number down there.
-3.
Okay. All right, so I know my x and my y. Sure keeps it. Remember, r is always positive, so my r is 3. Okay? So we were doing cosine, which is x. Cosine comes before sine, x comes before y over r. My x is 0, my r is 3, so that answer is 0. Okay? Now, you probably could have just did, if you're in degree mode, it'll probably tell you cosine of 270. All right? Cosine 270 should be 0. All right, make sure you're in degree mode when it's in degrees. All right? But again, you don't need the calculator if you learn what I've been trying to tell you. Secant of 90, okay? So 90's up here, okay? Pick a y value, Hannah.
7.
Okay. All right. So my r value would be 7 then also, right? There's my x, there's my y, my r is 7. Secant is a reciprocal of cosine, right? Cosine's x over r, so this one's r over x for secant. It's not theta, it's 90. It's just this. So r is 7, x is 0, so it's undefined. Okay? How would I put secant in my calculator? 1 over what? Cosine, right? So if you wanted to do 1 divided by cosine of 90, it should say undefined. Divide by 0. Right? You can't do that. There. Okay? 14 was cotangent of 90, which is 1 over tangent of 90, right? 1 divided by tangent 90. Another undefined. Right. 16 was -1. 18, cotangent of pi is undefined. Cosine of pi is -1. Right? Pi, remember, is where? What did I tell you where pi was? If you don't remember, how do I change it? Multiply by what? Right, 180 over pi. What happens to the pi's? So how many degrees is it? 180. So we're over here, right? So my x or my y value is 0. Tanner, pick an x value.
-5.
-5, right. Right. My r is still positive though. My r is from the origin to there, but it's always positive no matter where you're at. Okay. So for 20, with a cosine, remember cosine would be x over r. Right, so my x value is -5. My r value is 5. So the answer is -1. All right, cosine of 180. Oops, didn't give me my cosine. Cosine 180. There's our -1. Okay, if you want to use pi, what mode you got to be in? What do we call it? Radian. So if you want to use the pi, all right, you can go cosine and then hit second pi. And you'll get -1. Okay? So if you want to leave it in radian form, and you're using your calculator, just make sure, but again, I always like, again, I don't even use the calculator for these. I just draw my little picture real quick. Okay? So today we're doing very similar stuff. Okay? We're going to use reference angles, part 3. Yesterday we did 1 and 2. We talked about the quadrantals, that's like, the 90s, 180s, and 270s. Okay? You did any angle, that was the points. Here we got reference angles to evaluate trig functions. Okay? So the sign of a trig function depends on what quadrant the terminal side lies in. So here's an example. What are the signs of the 6 trig functions in quadrant 2? All right? So where's quadrant 2? Right there, right? So my picture, my terminal side goes straight back to the x-axis for your right angle. Theta is always back here by the origin. That's my point of reference. That's why they call it the reference angle. Okay? This x value is negative. This y value is positive. The hypotenuse is always positive, right? So sine in the second quadrant is opposite over hypotenuse, a positive divided by a positive, so that's positive. The cosecant, its reciprocal, will also be positive. The cosine, it's adjacent, a negative number divided by hypotenuse, which is always positive, so that answer is negative. You see how I'm figuring them out? And then secant, its reciprocal, would also be negative. Just flip that, right? Tangent of theta is opposite, a positive number divided by adjacent, a negative, so that's a negative. And then cotangent would just be the reciprocal, which is also negative. Second quadrant, 2 of them are positive. sine and cosecant. The other 4 are negative. That's how you figure that out real quick. Okay. If it said the 4th quadrant, I'd draw my little triangle down here in the 4th quadrant. Again, I just know that that number is negative. That number is positive. Hypotenuse is always positive. And I just look at my sign. That making sense? You should know that left of the origin are negative x values and to the right's positive. Above on the y-axis are positive numbers. Below the origin on the y-axis are negative numbers, right? You guys know all that stuff. So, right, Dominic? Real easy. Okay, oh, there was a picture I could have drawn there, I guess. All right, so again, if you want to memorize that table, you can. You don't have to. I just draw a little picture and do what I did, pluses and minuses. All right, so here's what we're looking at. All right, tangent is negative 7 over 5. Okay, so tangent, remember, is y over x. Opposite side over adjacent side. Okay, so if my opposite side is negative and my adjacent side is positive, where's that at? Remember, theta's back here, back by the origin. Opposite it are the y's, right? So I have a negative y. Where's the y negative? What 2 quadrants? 3 and 4, right? The x is positive. So we're in the 4th quadrant. That's a negative 7. And that's a 5. Theta's, remember, always back over there. Okay, opposite over adjacent. Negative 7 over 5. All right. His sine is less than 0 also. Remember, I know my hypotenuse is going to be a positive number. I got to figure out my hypotenuse. All right, how do I figure out the hypotenuse? Pythagorean theorem, right? So I got 5 squared plus negative 7 squared equals, c squared or r squared, however you want to remember it. So I got 25 plus 49, which is what? Is that a 74? So remember, I'm going to take the square root for c. All right. This is just saying the sign is negative. Opposite negative 7 over hypotenuse, the square root of 74. A negative divided by a positive is a negative, right? So I'm in the right spot. Okay? So that information in the beginning, this given stuff, tells me where to draw my picture. First, second, third, or 4th quadrant. Okay, Beard, what's the cosine of that picture?
5 over negative 7.
No. Close.
Negative 7 over 5.
No. Cosine. SOHCAHTOA. What's A stand for?
Adjacent.
Okay, so look at that theta, right? always back here. What's the adjacent side?
-7.
Straight across is adjacent, or is that opposite? Yeah. So that's
5.
yeah, 5 over. Again, it's asking for the exact value. So I need it like that. Can I simplify 74? Is there a number that goes into 74 like a 4 or a 9 or a 16? Is there a perfect square in there? 74 divided by 4? No, it doesn't work, right? I know 9 doesn't go into it, right? So there's no, I can't simplify it. Okay? But I have to rationalize it, right? So the answer would be 5 times the square root of 74 over 74. That's the exact value. It also asks for the cosecant. Okay? Cosecant is the reciprocal of which one? Sine, right? Sine is opposite over hypotenuse. So we want hypotenuse over opposite. So hypotenuse is the square root of 74. Opposite is -7. Okay? Those are the two answers for that problem. Right? They're going to give you some information. The information they give you is telling you where to put your right triangle, which quadrant to draw it. Right, Eaton? Yeah. Okay? So that was my opposite because it's TOA, right? Opposite was the -7. Adjacent was a 5. That's how I got that picture. My reference angle, my point of reference, is always back by the origin. Okay? All right. Again, you're supposed to know all this. And the reason you know all this is because you were supposed to remember this. 1 radical 2. That's the best. Right angle. Opposite to 30 is the 1. The hypotenuse is 2. Opposite to 60 is radical 3. Some of you had it backwards on the quiz. If you know that, you know this whole table. Okay? Then you just do SOHCAHTOA. Sine, opposite over hypotenuse. It simplifies the radical 2 over 2. Okay? Sine, opposite over hypotenuse, 1/2. Okay? So if you want to memorize that table, go right ahead. But I think it's easier just memorizing those two triangles. Okay, so it says cosine is -1/2. Remember? Adjacent over hypotenuse. X over R. Okay, my X value is -1, my Y value is +2. What quadrant am I in? X value is -1, Y value is +2. 2, right? -1, Y value is 2. Go back to the origin. All right. What's -1 squared? 1. What's 2 squared? 4. What's the hypotenuse? Square root of 5, right? What did I do wrong? I did that all wrong. What did I do wrong? Who can tell me? Not everything. Renita. I put the 2 in the wrong spot. Sorry. That's the hypotenuse, right? You're supposed to make sure the old man doesn't make mistakes. That's how you're supposed to know. All right. So hypotenuse was 2. I put it on the Y. My bad. It said the opposite side was radical 3, and the hypotenuse was 2. So there's my picture. All right. So we're supposed to find the cotangent. All right. Cotangent. Tangent's opposite over adjacent, so cotangent would be adjacent over opposite. And then we'd have to rationalize it. So that's the answer. So again, I put adjacent hypotenuse, but when I wrote it, I didn't put the 2 in the hypotenuse. I put it on the opposite side. My bad. Don't make those careless mistakes. So. All right. It says, given an angle in standard position, its reference angle is the acute angle formed by the terminal side and the original angle of the original angle and the x-axis. Okay? So, if I'm in the first quadrant, the reference angle is whatever you got. All right? Somewhere between 0 and 90 degrees. If you're in the second quadrant, all right, between 90 and 180, your reference angle is between this side and the x-axis. So if that's a 120, that's going to be 60. If that's a 170, that's going to be a 10. Right? The reference angle is always between the x and that line, which is the hypotenuse. Okay, we're always going to be inside the right triangle, backed by the origin. If you're in the third quadrant, okay, you're between 180 and 270. That's what this is saying. Okay, so whatever your angle is, like 225, subtract 180 from it, and that'll give you like 45 for your reference angle. So it's whatever the angle is minus 180 to get the reference angle. That little mark next to theta, it stands for reference. If we're in the fourth quadrant, we're between 270 and 360. All right? Remember, the reference angle is always between the hypotenuse side and the x, back inside there. So this is going to be 360 minus whatever they give you. You know, if we're at 300, that went to 300 there, inside there's 60 degrees. That's the reference angle. Okay? So, find the measure of the reference angle. 120, if I drew it, would be from here to there, would be 120. I'm looking for that. How many degrees would the reference angle be? 60. Because to there's 180, so it's between 180 and 90. Okay? 345. Okay? All right, 345, 180, 270, 345 is over here. Okay? So how many degrees is in there? 15, right? 360 minus 345. Okay? What if it's 7 pi over 4? What I usually do is this. I change it to degrees. 7 times 180 divided by 4. So that's 315. That way I know where it goes. So 315 to there, what's the reference angle? 45. Okay? Then you got to change it back. So 45 pi over 180 is pi over 4. When you simplify it. Okay? So if they give you the problem in radians, your answer should be in radians on the reference angles. 210, where's that at? First, second, third, or fourth quadrant? Third, right? So I would draw my picture of my triangle in here. All right? 210 is how much more than 180? 30, right? So it's a 30-60. Opposite to 30 is 1. The hypotenuse is 2, but this will be negative 1 because I'm in the third quadrant. And this would be the square root of 3. So what's the sign? Opposite over hypotenuse. Okay? Draw the pictures. This is what I'm going to ask you to do on Friday. All right? We're running out of time. So I won't show you those two examples. There's your homework. Time to wake up and start doing some work. Don't stop working. You've done really well up to this point, most of you. It doesn't take long to drop if you decide to not do anything. You still owe me stuff.
He needs to take his quiz, like tomorrow.
What's that? You ready for a quiz tomorrow? Is that what you said?
No, it's what Justin said. Justin said he's ready for this quiz tomorrow. He wants to take it.
Yeah.